Hello, in this video, we're going to be looking at the first part of lesson 6.6, which covers properties of kites. In the day 2 video, we'll look at properties of trapezoids. The essential question for this lesson is what are the key properties of kites and trapezoids? Let's start by defining a kite. A kite is a quadrilateral that has exactly 2 pairs of congruent consecutive sides. Notice in this picture that AB is congruent to AD, and those sides are consecutive. They're right next to each other. And BC is congruent to CD, another pair of consecutive congruent sides. There are 2 specific properties of kites. The first property is that if a quadrilateral is a kite, then its diagonals are perpendicular. So if we look at this picture here, the diagonals are GJ and HF, or FH. Notice that GJ and FH are meeting at a 90-degree angle, so they are perpendicular. Also note that all 4 angles are 90 degrees, so you really just get like 4 different right angles. If you'd like to abbreviate this theorem, you can either call it theorem 6-6-1, or you can use kite arrow diagonals perpendicular. That means if something's a kite, then its diagonals are perpendicular. Moving on to the second kite property, theorem 6-6-2, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. So notice in this picture, angle G is congruent to angle J, but angle F is not congruent to angle H. Sometimes it's helpful to give these angles specific names. So the angles that are between the congruent sides, so for us that's angle F and angle H, those are called vertex angles. So F is between the 2 sides with the 2 tick marks, and H is between the 2 sides with the 1 tick mark. Those are vertex angles. The 2 that are congruent are the non-vertex angles. So angle J and angle G are the non-vertex angles. And in any kite, the non-vertex angles are going to be the 2 angles that are congruent. Now that we have these properties down, let's go ahead and solve some problems related to kites. Here we're given that EFGH is a kite, and we're told that the measure of angle FEJ, which I'm going to follow along, that's this angle right here, is 25 degrees. And we are also told that the measure of angle FGJ, which is this angle right here, is 57 degrees. And we want to use those to find each of the missing measures. Now, one thing that's going to help us first is that the diagonals of a kite are perpendicular. So this is a 90-degree angle right here. And when we're asked to find the measure of angle GFJ, that is this angle right here. And I want you to kind of pay attention to this triangle that I just outlined in purple. So in triangle FJG, we know that the 3 angles inside a triangle always add to 180. And since this is a right triangle, we already have 90 degrees covered. So I can either take my total 180 and then subtract 90 and then subtract the 57 and get 33. Or since we know that this is a right triangle, we could also just do 90 minus 57, and that would be 33 as well. So that gives us angle GFJ is equal to 33 degrees. Now let's move on to calculating the next one. So we want to find the measure of angle JFE. JFE FE. That's this angle right here that I just colored in orange. Once again, I'm going to use the triangle. So if we focus in on triangle FEJ, that's this one that I'm outlining in orange, we again have a right triangle, so I could either start at 180 or just start at 90 and subtract 25. And when we do that, we get 65. So the measure of angle JFE is 65 degrees. I'm going to fill that in on my picture. It's always helpful to fill in the numbers on the picture as you find them. So let me also add that little angle there we calculated was 33 degrees. So now the final angle that we want to calculate is the measure of angle GHE. And angle GHE is this angle right here. It's that big angle. Well, the first thing we can do is we can find the measure of the two smaller angles. And one thing to note too is that the non-vertex angles are congruent. So in the kite, EFGH, by that kite property number 2, we know that angle EFG must be congruent to angle EHG. And I can find this angle right here by calculating the 33 and the 65 added up. So 33 plus 65 is equal to 98. So that means that the measure of angle GHE is 98 degrees. Let's try another example. For part B, we do not have any of the diagonals drawn in, but what we do know is by kite property 2, we know that angle E has to be congruent to angle G. We also know that since this has 4 sides, the angle sum, which is n minus 2 times 180, is going to be equal to 4 minus 2 times 180, which is 2 times 180, or 360 degrees. So the 4 angles in any quadrilateral, and a kite is a quadrilateral, will always add to 360. Since angle E and angle G are congruent, we can call them both x. Now, if I add up the 2 angles, I know 100 plus 40, and then I add the x's up, because those are both the same, it has to total 360 degrees, which is the total angle sum in a quadrilateral. Now it's just basic algebra. We have 140 plus 2x equals 360. I'm going to subtract 140 from each side to get 2x equals 120, and then we'll divide by 2 to get x equals 60. So that means that we have the measure of angle E and the measure of angle G are both equal to 60 degrees. So that's going to be measure of angle E equals 60 degrees, and measure of angle G is also equal to 60 degrees. To double check your answer, you could add up the 3 angles now. And if I do 60 plus 60 plus 100 plus 40, that should add to 360. And if we calculate these 4 numbers added up, we do get 360. So that means we have the answer correct. Now let's look at the try now example. If you'd like to try this problem on your own, you can definitely pause the video. If you'd like to go through it with me, keep the video playing and we'll talk through it right now. First, we're given that in kite ABCD, the measure of angle DAB is 54 degrees. So DAB is this big angle right here. Okay, D to A to B, and that is 54 degrees. And then the measure of angle CDF is 52 degrees. So CDF F is going to be this angle right here, and that is 52 degrees. So now let's work to find the measures of the other angles here in the kite. Find the measure of angle BCD. Well, the first thing I'm going to do here is mark in my 90-degree angles because we know in a kite the diagonals are perpendicular. So this right here gives us a right triangle, and that's going to be a great starting point if we look at this right triangle up here that I just outlined in blue. Since it's a right triangle and one angle is 52 degrees, if we just take 90 and we subtract 52 from that, that's equal to 38 degrees. So this angle here is 38 degrees. And then since this is a kite, one fun fact to know about kites is you basically get two congruent triangles. So this angle, and it's all by, I guess it would be the HL theorem, because they share this leg, and the hypotenuses are congruent because in a kite, we have those consecutive congruent sides. So essentially the easiest way to do this is just to look and say, okay, well, if I mirror this angle here is 38 degrees, and then this angle here is 52 degrees. Well, now to get the measure of angle BCD, notice in the picture that the measure of angle BCD is just those two 38s put together. So 38 plus 38 makes 76. Next, let's look at the measure of angle ABC. That is this big angle right here. There's definitely more than one way that we could figure out this answer, but one thing that we do know is in a kite, the angles that are right here, the non-vertex angles, those are congruent. So if I look at those two angles that I just marked in black, and I put the X and the X, and then I add it with the 54 that I know, so I'm looking at my big kite, 54 degrees, and then we just found this angle right here was the 76 degrees, so I can add that. We know that in a kite, which is a four-sided polygon, the sum of the angles in a kite is going to be n minus 2, so 4 minus 2 times 180. Well, 2 times 180 is 360, so our angles have to add to 360. Well, now let's go ahead and do our algebra here. 54 plus 76 is 130. X plus x is 2x. And then I can solve it from there, subtract my 130. So that gives us 2x equals 230. And then we can divide out the 2 to get x equals 115. So that big angle there, both of these angles are 115. So let's go back to our picture now. And where I have those x's, I'm going to erase that and change those to 115. Now, how is that going to help us answer the rest of the question? Well, look carefully at angle ABC. We just found that was 115. FDA we can also find next. Notice that FDA, F to the D to the A, is this little angle right here. Well, that purple piece plus the green 52-degree angle has to equal the 115. So if I look at this kind of visually, and I really love my colors here, the 115, if we subtract the 52 from that, that's going to be equal to 63. So this little purple angle here has to be 63. That way, if I put the 63 and the 52 together, notice how those add back up to the 115, which is that full angle that I've marked here in black. So that was a really amazing problem. Lots and lots of calculations to do. That's as hard as it gets. But I like it because it reviews a lot of properties of triangles and kites. So that's it for the day 1 portion of lesson 6.6. Thanks for watching and good luck as you practice some kites on your own. Bye.